All right, welcome back everybody. We're going to talk about this particular special right triangle. There's only two of them, so don't think that it's too overwhelming. It's a little weird at first how you apply this formula to the problem you're given, but I really want to stress that we're not talking about SOHCAHTOA anymore. There's no opposite over hypotenuse anymore. We're only going to be talking first about the 45, 45, 90 triangle. And there's kind of a formula for each one of these. So on the long side of a 45, 45, 90 triangle, right, this is longer than these two sides. Well, it's going to be a little bit longer than this one and this one. With triangles, if I have the side across from a 45-degree angle, and I have another side across from a 45-degree angle, these sides are going to be the same. So in your book, hopefully they use the letter A for the side, because I don't want to confuse it. In examples in the book, in your homework, it's going to be using like solve for x, but this is the general formula. So I don't want to mix up x's, so we're going to use A. So let's say that this side is A and this side is A. Well, then this side's a little bit longer. This side is A times square root of 2. All right, now I drew these other two triangles because it doesn't matter what the orientation is. The right angle could be down here, right? And that's just the same thing as all of these. So you need to pay attention to what's across from the 45. Well, across from the 45 is side A. Across from this 45 is side A. This side would be A times root 2. And I'm going to give you a couple seconds. Think about this one. Where would the A be? If you said here, maybe you're wrong. Well, yeah, this is across from the 45. Sorry, this is across from the 90-degree angle. So across from the 90-degree angle is this. The long side, the hypotenuse, is A root 2. Across from the 45 is A, and across from the 45 is A. All right, so it always will be like this. And how do you apply this to a real problem? Or what are they asking for? So they're probably going to give you a 45, 45, 90 triangle, and you'll know because it has a right angle, and a lot of times it'll only give you 145. Well, we know that all three angles in a triangle equal 180, so it would be like 180 minus this 90 minus that 45. That leaves me with 45. Okay, so that means this angle has to be 45. And they're going to give you at least one side. I'll start off with a little easier one. So let's say that this side is 8, right? Well, because this side and this side are the same, I know that across from this 45 is 8, so across from this 45 is 8. And what's this side? Well, if this was 8 and this was 8, then this would be 8 root 2. Okay, so that's going, if you know the 45 sides, it's pretty easy. But if you don't, if you only know 45, 45, and 90, let's say you only know that this side is 10. All right, well, what's this side and what's this side? So here's how I want you to always solve these. You set what you have equal to what this is in like the template, right? So if this is 10 and this is A root 2, those are the same thing. So when they're the same thing, it gets an equal sign. So 10 is equal to A root 2. All right, this side is A, this side is A, but what is A? Well, A root 2 is 10. How do I get A by itself? Give you some time to think. And, well, we're going to divide by root 2 to get it out of there. Okay, so this root 2 is now gone. 10 over root 2. 10 over root 2. And hopefully if your math teacher knows what they're talking about, you can't have a square root in the bottom. It's just because it's not like clean enough. This is not a fully formed, you can't divide by a square root. So you need to get rid of it. So to get rid of it, we're going to multiply by the same thing on top and bottom, because a square root times a square root, this gives you the number itself. And then we have 10 square root 2 over 2. Last little step here is 10 over 2 can be simplified to 5. And then the root 2 is there. So I no longer have a square root in the bottom. So that means A is 5 root 2. So this side is 5 root 2, and this side is 5 root 2. Okay? So, a little recap. We're not doing SOHCAHTOA anymore. We're looking at 45, 45, 90 triangles. And they're always this template. The long side is A root 2. And a trick to remembering this is 45 has, you can divide 4 by 2. So this is the root 2 triangle. When we look at the 30, 60, 90 triangle, there's a root 3. So the 30 and the 3. This one's going to go 45 and 2, 4 and 2. I'd say this one is a little bit easier because these sides are the same. When we get to the 30, 60, 90, all three sides are different, but they're linked to each other, so it won't be that bad. But I wanted to start with the 45, 45, 90 because it's a little bit easier. And we'll do a couple more examples in another video, but so far, if you know the 45 side, it's not that bad. But if you know the hypotenuse, you set the hypotenuse equal to the A root 2 side, and then solve for A. All right.